Hello and welcome to another GCSE revision video, and in this video we're going to be looking at the three-dimensional shape, the prism. A prism is any 3D shape that has a uniform cross-section all the way through. Now both ends of a prism will look the same. So if you've got a two-dimensional shape and that shape is just extended into the third dimension, then you've got yourself a prism. So you can cut that prism, and wherever you slice that prism it will always have the same shape, so long as you're slicing along the correct axis. So for example, a cube, a cuboid, a cylinder, they're all prisms. Now that means that the volume of a prism is just the cross-sectional area multiplied by the depth or height or whatever you want to call it. The surface area, like with any three-dimensional shape, is just the sum of the areas of all the faces. So one of the simplest prisms is just a cylinder. It's just a circle, and that is then extended into the third dimension. Now the area of the curved face of the cylinder is just the circumference of the circle extended into the third dimension. So that's just 2 pi r h, where h is the height of the cylinder. The area of the top and bottom circles is, like for any circle, is just pi r squared. So the total surface area of a cylinder is 2 pi r squared plus 2 pi r h. And if you really like factorising, you can factorise the 2 pi r out, so you get 2 pi r into r plus h. Now the volume of the cylinder is just pi r squared h. It's the area of the circle multiplied by the depth or height or whatever it is you want to call that dimension that you're extending the circle into. Now the cube is a regular hexahedron, that is to say it's a three-dimensional object that has 6 faces. It's made from 6 congruent squares. As such, the surface area is just 6 times the area of one of the squares. Since the area of the square is just the length squared, the surface area of a cube is just 6 times the length squared. The volume of a cube is the cross-sectional area multiplied by the height, but since the height is the same as the length and the width, then it's just length times length times length, which is length cubed. The surface area of a square prism is the sum of the 6 faces, 2 of which are square and 4 are rectangles. So the surface area is just 2 times length squared plus 4 times length times height. The volume of a square prism is just the cross-sectional area multiplied by the height. In this case it's just length squared times height. The surface area of a rectangular prism is the sum of the 6 faces. The opposite faces will be congruent. So the surface area is 2 times length times height plus 2 times height times width plus 2 times length times width. The volume of a rectangular prism is the cross-sectional area multiplied by the height, just like with any prism. So the volume is just length times width times height. Okay, well, so much for the theory. Let's have a go at putting that into practice. Can you use your knowledge of prisms to work out the surface area and volume of this triangular prism? Take your time, pause the video, and when you're ready for the answer, just press play. Okay, so how did you get on with that question? Alright, so let's take the easiest part first, I think. Let's do the volume. Like for any pyramid, what am I talking about? For any prism, the volume is just the cross-sectional area multiplied by the height or depth or whatever you want to call that third dimension that the two-dimensional object is extended into. So now for a triangle you would usually say half base times height, but in this case the height of the triangle is not necessarily the same height that we're talking about, so the word height can be a little bit ambiguous here. So for ease I've actually not given the height of the triangle. If you want to, you could get the height of the triangle and then multiply it by the you would probably then call this dimension the depth, and you could then calculate it that way, half base times height. You would have to use your trigonometry to get this height, which is not difficult. It's perfectly simple. That's just that's just A times sine C, which would give you this height, and then you could multiply that by half of B, which would give you half AB sine C, which is the formula I would use anyway. So I would say the area of this is just a half AB sine C. That's the area of the triangle. And now for the volume of the triangular prism, I would just multiply that by the height. And I could simplify that a little bit by just saying that's height over 2 times AB sine C. I just tidied this up a little bit. And that's all there is to it for the volume. Now the surface area, like for any three-dimensional shape, is just the sum of all the surface areas. Well, we already know that the surface area of the triangle faces, there's two triangle faces, one at the front and one at the back. So that's just 2 times a half AB sine C. And the 2 and the half can cancel out, so we're just left with AB sine C. And to that we need to add our 3 rectangular faces. So this face is just H times A. This face underneath is just H times B. And the face that's hidden, that we can't see, is just H times C. So the surface area is just AB sine C, which takes care of the 2 triangular faces, plus HA plus HB plus HC. And if you feel like tidying that up, I would be inclined to take the H out, and I would say it's AB sine C plus H into A plus B plus C. And that's all there is to it. Okay, if you liked this video, please show your appreciation with that like button. Also use that like button if you want to see more videos like this. Use the comments section if you have suggestions for other GCSE maths related videos. If you're also stuck while you're doing your revision, use the comment section, just ask, and if I can answer, if I can answer, I will answer. And don't forget to hit that subscribe button if you want to be notified. You'll also have to click notifications on, then you can be notified when the videos are uploaded. so you're not waiting around and constantly checking. Other than that, if you're taking your GCSEs this year, I'd like to wish you every success with your exams and your revision, and I'll look forward to seeing you in another video.